So in this series, what I'm going to do is I'm going to go through how to make an HLSL Uber shader. So an Uber shader is a shader that can do basically everything we need. You should be able to use this shader for nearly all of your materials. The default URP lit shader is an example of an Uber shader. So I'm going to show you how to recreate that and all the different nitty-gritty details about how HLSL works. So to start off with, I just have a scene here. And in this scene, I just have a sphere. This is what we're going to be testing on. So there are two main parts to a shader. There is the fragment and the vertex. So the vertex runs first, and it deals with all the different vertices on a mesh. So all the points where these lines meet is going to be a vertex, and we can modify those in our vertex shader. The fragment shader deals with the actual color. It tells the GPU what it needs to draw for each pixel visible on the screen. Now, while the two main stages are vertex and then fragment, there is a third stage that falls in between, and that's the geometry shader. The geometry shader deals with actual triangles. So when Unity gives me the wireframe here, each triangle in this can also be passed to the shader, and we can do different things with it. So when you're modifying a vertex, it's doing it before the triangles are drawn, whereas if you're modifying a trie, it does it after the triangle's already created. So you can create some different effects with it. I'm going to show you exactly what I'm talking about all throughout this series. First thing we're going to do is we're going to create a URP unlit shader. So just go create shader URP unlit. We're going to call this universal test shader. While we're at it, we're also going to create a material from it. We're just going to call this universal test material. We're going to apply this to our sphere. So if we open this up and we head over to Visual Studio, this is what pops up in Visual Studio. So there's a few things here, but we're going to ignore most of this, and we're just going to go down to the two stages. So in these two stages, the first one is going to be the vertex, which is what this vert is. And there's also a frag, which is our fragment. The vertex deals with figuring out where the object is. So position HCS is the position in clip space, which is where it is relative to the camera's clip planes. This is how the renderer knows where on screen to draw something. So this is a mandatory property of a shader. You need to create the clip space position, or else it'll never know where to draw it. And then we also have our UV. U and V are just other ways of saying X and Y. It's X and Y in terms of texture coordinates. So U is X, V is Y. And these tell us where to sample a texture. And then in our frag, in this case, all it does is it samples our base texture and multiplies it by our base color and returns the color. Now, this doesn't have a geometry shader in it. We will add one later on, but for now we're just going to start simple with vertex and frag. If we go up here, there are also two structs at the start. There's a struct attributes, which takes in the object space position of each vertex, as well as the UV. And then there's a struct varyings. This has the clip space position and the UV as well. The shader always takes in attributes. Attributes are fed directly from the GPU, or from the CPU to the GPU, and it tells the shader the necessary information about where it exists. So we take in an attribute struct and we create a varying struct. We're returning a varying struct from it. So we define the out, we set the values, and we return that. The frag takes a varyings in, and it uses that to determine where it's going to sample things. Your frag also has this SV target here. This is needed in order for it to render properly. But that's the basics of it. We take the attributes, which is delivered to us from the CPU. We feed it through this varyings vert, and then it creates a varyings from it, and that varyings is fed to the frag. That's the basics of how a shader works. It needs these values to be fed to it, and then it returns the proper color. We also have to pragma the vertex as vert and fragment as frag. These are keywords to the GPU telling it exactly what it's supposed to do. These are built directly into DirectX. You will never need to modify these. These are pretty low level. You should just leave them. The hashtag pragma is a compiler directive, so it's basically telling it that it needs this script to function. It needs this part of the shader. So it's pulling this from DirectX, and it's telling it that vert is a vertex function. So it knows what to do with it. Same thing with frag. Then there's also includes. This is the same as, say, putting using in your C# scripts. This is just a way to include a library. So by default, you will pretty much always need the core.HLSL, but you may also need lighting, a few other different things that Unity offers, depending on what your shader is supposed to be doing. So that's the basics of it. In the next video, I'm going to show you the start of how to create color, how we can color an object.